Alright, so today we're going to talk about operations with radicals, which means we're going to add, subtract, and multiply. There's some rules to these. For adding and subtracting, just like with anything else, you can only combine like terms. What that means for radicals is the radicand and the index have to match. Or in other words, they have to be the same type of radical, so both square roots, both cube roots, and have the same number or combination of numbers and letters underneath. So for example, let's do a couple of these. If I want to do 2 square root of 24 minus 2 square root of 54. Now right now, these are not like terms, but maybe if we simplify them, they'll become like terms. So let's do a little bit of scratch work here. 2 square root of 24. Well, if I was going to simplify 24, that's 4 and 6. 4 is 2 and 2. 6 is 2 and 3. So I can pull out a pair of 2's. I have a 2 and a 3 left underneath. So I have a 2 outside, a 2 that I pulled out from here, and a 2 times 3 underneath my radical. For 54, 54 is 9 times 6, which is 3 and 3, and 2 and 3. So we're going to have a pair of 3's. We have the 2 that was outside before. We have the 3 we pulled out from our pair, and underneath the radical we have a 2 times 3. Now if we simplify all that, 2 times 2 is 4, 2 times 3 is a 6 underneath the square root, 2 times 3 is 6, and we have a 6 underneath the square root here. Now these are like terms because they're both a square root of 6. Now all you have to do is combine the coefficients, or the numbers on the outside. So 4 minus 6 is negative 2 square roots of 6. Let's do another example. This is the same idea. We're still adding and subtracting, but now they're cube roots. And again, right now, I don't have like terms. They're all cube roots, but they don't have the same number underneath, so I need to do a little bit of simplifying. Now this one isn't going to simplify really at all. So negative cube root of 6 is just going to have to stay the same. Here, it's almost right, but this negative is messing us up. If you remember from yesterday, the cube root of a negative 1 is negative 1. So when I simplify this, I can just pull out this negative. Let's make this, right down here, negative cube root of 6. Now if I pull out a negative, negative 2 times a negative 1 is going to be a plus 2 cube root of positive 6. Here we actually have to do a little bit of work. So do your factor tree. 24, let's say 2 times 12. 12 is 2 times 6. 6 is 2 times 3. Because this is a cube root, we're looking for groups of 3. So there's 3 2's with a 3 left over. So I have this 2 on the outside. I'm pulling out a 2. Those will get multiplied. And I have a cube root of 3. So if I simplify this a little bit, I have a negative 1 cube root of 6 and a positive 2 cube root of 6. Those are like terms. Negative 1 plus 2 is a positive 1 cube root of 6. And you can write the 1, but you don't have to. 2 times 2 is a 4 cube root of 3. Now these are not like terms, so this is my answer. That is as simple as we can get on that one. So that's adding and subtracting. Let's talk about multiplying. Now for multiplying, the rules are a little bit different. To multiply now, only the index has to match, which means they have to be the same type of root, both cube root, both square root, whatever, but the number underneath does not have to match anymore. So for example here, let's do square root of 10 times square root of 15. They're both square roots, so we're allowed to multiply them. You may want to simplify first if you can, but 10 is just 2 times 5, 15 is just 3 times 5, so I can't really simplify at this step. So all we're going to do is keep the square root, and we're going to multiply the insides. So 10 times 15, all underneath that root. Well, 10 times 15 is 150. So now we've done the multiplying, we just need to see if we can simplify. So let's make a factor tree for 150. That's 15 times 10. 15 is 3 times 5. 10 is 2 times 5. So square root, so this pair of 5s can come out. This 3 and this 2 have to stay underneath. So that's 5 square root of 3 times 2, which is 5 square root of 6. Now that was kind of an easy one. Let's look at something a little bit trickier. So still nothing really is going to simplify before we start multiplying. But now I have these parentheses. And just like anything else with parentheses, a number in front of parentheses, that should make you want to distribute. So that's what we're going to do. Now square root of 15 times 2, this is not a square root, so it's just going to go right on the outside. 2 square root of 15. Square root of 15 times 4 square root of 3. The 4 will still be on the outside. The 15 and the 3 will both be on the inside. Now we just have to simplify and see if maybe we can add, see if we can get like terms. So this is still a 2 square root of 15. 15 times 3 is 45. So let's see if we can simplify the square root of 45. Which you know is 5 times 9. 9 is 3 times 3, so I have a pair of 3's to pull out and a 5 to stay underneath. So that 3 is going to get multiplied by this 4 to make 12. And this 5 that's by itself has to stay underneath. Now these are not like terms. 15 and 5 don't match for addition. So this is as far as you can go. Now for our last example, this is the hardest one yet, because we have two sets of parentheses. But the idea is still the same. We've done problems that look like this before. They just didn't have square roots in them. So we're going to distribute. Negative 7 times 2 is negative 14. Negative 7 times negative 5 is going to be a plus 35. And the square root of 5k is just going to come along. 2 square root of 5 times 2, well 2 times 2 is 4. Square root of 5 comes along. 2 square root of 5 times negative 5 square root of 5k. You multiply the 2 and the negative 5 because they're both on the outside for a minus 10. On the inside you multiply the 5 and the 5k for a 25k. Now the only thing we can do is simplify any radicals that you can and try to add things together if they're like terms. So negative 14 doesn't have a radical. I can't really simplify 5k. There's nothing to pull out there. I can't simplify 5. Looks like the only thing I can simplify is this 25 right here. The square root of 25 is 5. Which will come out and get multiplied by this negative 10 for a negative 50, square root of k. So we've simplified as far as we can. None of my radicals match. So this is the simplest answer. If you see one that's that long, no worries. That doesn't necessarily mean you're doing it wrong.